As we saw in the pre-analysis, the domain over which we want to solve the governing equations is a rectangle. I'll show you how to create that rectangle in ANSYS. Before I get into ANSYS, I wanted to make a note about version differences. When I created this module originally, the latest version was version 16, and so I recorded the videos using version 16. Now it's about a year or so later, and the latest version is 18.2, and ANSYS 18.2 is the version we are recommending for the 2018 edition of this course. Most of the things are the same between the 2016 and the 2018 versions. One major difference is that the default geometry engine in the latest version is SpaceClaim, and that's going to be the geometry engine going forward, and it's for most part much more capable than the old geometry engine Design Modeler. So the geometry steps will use are recorded using version 18.2 and SpaceClaim, and then when the videos with the meshing and in the Fluent solver are for the most part going to be the old videos from version 16 because things haven't changed that much. So you have to get used to seeing, videos recorded in different versions, and look out for clues within the annotations within the video if there are minor differences. And also look at the FAQ where we will make notes about version differences that people have encountered. If I go back to one of the slides from the pre-analysis, we saw that the domain is a rectangle of length equal to the length of the pipe and height equal to the radius of the pipe. And so we will need the Fluent solver to solve the governing equations in that rectangular domain, and we will specify boundary conditions at the edges of the domain. Let me start ANSYS. So I can start it from here. I can go here and I can look for Workbench 18.2 over here, or I can go in and type in Workbench, and I'll pick Workbench 18.2 and twiddle your thumbs a bit before the Workbench interface comes up. And here you see different analysis systems, and you can think of them as, giving you access to common mathematical models that arise in engineering. For instance, in 2D conduction, we use steady-state thermal, which gives us access to a solver for the steady version of the heat conduction equation. We will use this solver, Fluid Flow Fluent. There are two solvers for the Navier-Stokes equations, CFX and Fluent. I haven't used CFX. We'll use Fluent. So click on Fluid Flow Fluent and drag it into the project page. And I'll leave the default name on here and come to Geometry and right-click on Geometry and go to Properties. And we have a two-dimensional problem, so I will set the analysis type to 2D. And it's critical you do this right at the start, or at least it was critical. Apparently, this is less critical with SpaceClaim as a geometry engine. But I think it's a good practice to come and set the analysis type to 2D. I've gotten burned by forgetting to do that, and it can be uncomfortable when that happens. So set that to 2D. Now with these two, selecting that analysis system and setting it to 2D, it already has important clues on what the governing equations are. So if I go back to my slides here and go back to the governing equations, it hasn't turned on this version. It has turned on the 2D version of the conservation equations. So in fact, the equation that it has would be du dx plus dv dy, which most of you would be familiar as a 2D version. So it's turned this on, and we will have to convert it to this version of the conservation equation, similarly for momentum, and we'll do that later in the Fluent solver. But I just wanted to alert you to the fact that it's already used, couple of clicks as clues to turn on the governing equations that you want to solve. So I can exit out of there, and next I will go into geometry and create the geometry within space claim. So that's what is coming up next.